Hello everyone, and welcome to this session on how Genesys reinvents contact centers with serverless. I'm Jean Marat, I'm a solutions architect with AWS, and in this ISV track, we want to give you information that's especially valuable for companies that build software as their main activity. And so we're going to focus more specifically on how serverless solutions can bring value to a company that's working at the scale and with the mission-critical software that Genesys is bringing. Okay, so we're going first to go for a quick overview of what Genesys Cloud is and what the background of Genesys Cloud with AWS is. And then we'll go into what serverless means and how it's more than just Lambda. When you can decide to add serverless services into the software that you're building, what criteria and what challenges come with bringing serverless solutions into your software solutions, and how Genesys has implemented and overcome these challenges. And we'll wrap up with the benefits that it brings to the Genesys Cloud team. So to take us through these points, I'm happy to introduce Glenn Nethercutt, who's the Chief Architect and Fellow at Genesys Cloud. Glenn, the floor is yours.
Thanks, Jean. First, a little bit about who we are. Genesys is a customer experience company. We've been around for over 30 years. And we power every year over 70 billion interactions of some of the world's greatest brands. And we do that across over 100 different countries. We're an experience as a service company. In particular, the part of Genesys that I represent is Genesys Cloud. We have a number of different offers. Mine is one that has its origins in cloud native design. We looked years ago and noticed that there were a lot of consumer market leaders at the time, the Netflixes of the world, that were focusing on things like microservice design, immutable architecture, continuous integration, continuous delivery. And we wanted to apply those learnings and techniques that were being used there in the consumer market to the enterprise market as well. So we wanted to have a faster and more tailored way to build these personalized experiences to connect brands with the users and who was actually able to leverage it. And we wanted to do that by creating both a product, but more importantly, a platform, because we also saw the need, all the builders that were starting to arise really inside of the cloud ecosystem were struggling and needing to have new ways to personalize and create things on top. And we wanted to go with an API first and a platform focused approach in order to achieve that. Fast forward a bit, we've been around since inception for about 7 years. We're now in 12 different AWS regions in production, 10 core to what we like to call satellite regions. We're comprised of over 400 different microservices, thousands of Lambdas, many thousands of DynamoDB tables, etc. We do all of that with incredibly high uptime, thousands of deployments into production daily, hundreds of thousands of users, thousands of customers. And a big part of the story, a big part of how we're able to achieve that is with technologies like serverless in particular. And that's what I'd like to kind of talk about a bit today. Here's an example, though, of the type of customer that we wanted to enable. One of the more advanced customers, in this case, it's Textile Fashion Group, a global retailer. And they were looking for a product. They were looking for SaaS, and they also wanted a platform. They needed the ability to customize. So that's the segue into serverless is a powerful enabler. It has a big role to play in creating these types of integration experiences and rich ecosystems around it. So first, let's start off with what is serverless. There's a lot of nebulous descriptions and definitions that are out there. Most commonly, I would say people do talk about it in the rubric of compute. They talk about AWS Lambda, and that's fine, but I think it's a bit reductive. I think if you look at what is out in the ecosystem of AWS, there are lots of things that meet the criteria to be called serverless. For example, DynamoDB is a serverless data tier. It's come a very long way, I think, from its original HA key value store origins. It's got a lot more business capabilities and power that's been sort of grown over time, things like DynamoDB Streams, for example. And I guess that's sort of illustrative of one of the truer forms of what I think is really serverless. It's a SaaS API. It's consumption-based, where you aren't actually defining the infrastructure things are running on. You're just consuming a service. But it's a spectrum. There are a lot of things on this list that you might see here that you may not necessarily have couched yourself as serverless, but I'd say they all exist somewhere along that continuum. The qualification for me is anytime you're not defining servers and classic infrastructure, it's probably a serverless form of technology in some way. Another way to think about it is you're starting to work in the currency that's closer to the workload as opposed to an artificial one. So back to DynamoDB, for example, you're dealing with IOPS. For S3, you're dealing in gigabytes of data stored. For Athena, you're dealing with terabytes of data being scanned by the query engine. So all of those have sort of moved up a value chain in how you consume them and made the currency that you deal with closer to the business problem. So that's sort of the what, but let's talk about the when, the how, and the why. So within Genesys Cloud, we've got a Lambda first mentality now. We'll talk a lot about Lambda in this session, mostly because I think that's how people have considered serverless, and it's probably why you've come to this talk to hear how we've particularly leveraged that piece of serverless. So we'll focus mostly on that, but you'll hear an undercurrent of themes that I think you can apply to the other technologies as well. So we do have a Lambda first mentality. For us, that means if a new service comes along, we want to offer a new business capability. The team doesn't answer whether or not they would be EC2 or Lambda. It's why not Lambda. I think that's a good definitive direction that you can set for a company if you want to strongly bias towards serverless. That being said, there are some really strong characteristics that would imply a fit, and there are definitely contraindicators as well, things that don't necessarily drop into the Lambda world as easily. Certainly, if you have event-driven workloads, that's a maybe good characteristic. It doesn't disqualify you. It doesn't make it's a slam dunk for Lambda either. You can certainly do event-driven on EC2, but event-driven is a good distinctive quality to have. Statelessness is key. In Genesys Cloud, we have, again, hundreds of microservices even built on top of EC2, and we strive to have all of those also be stateless. We externalize our state wherever we can, outside of data tiers, obviously. But the idea that some forms of state can make their way into EC2 isn't something that can really make its way across the divide into Lambda. So if you've got that, statelessness, Lambda may still be a fit. If it's a sporadic workload, that's another great indicator that Lambda might be a good idea. There are lots of CRUD operations, administrative actions, things that happen at human speed rather than at system speed. They're infrequent, and that can mean that the cost effectiveness of Lambda is a good qualifier to make it a great choice. And the lifetime of the duration of an individual request of handling an event is an important criteria as well. The Lambda team has obviously gotten more gracious over time in giving us more and more runtime. For us, though, we've decided that anywhere in the 1 to 2 minute range is probably a good time to start thinking, is this a good fit for Lambda? Certainly, if it's in the many minutes or hours of runtime, then it's not a fit at all. So we strive to keep those runtimes as short as possible for each Lambda invocation. Some of the contraindicators, though, hard real-time. Our business is customer experience. A lot of that is still driven by voice interactions, sometimes through the web, many digital. But many regulatory bodies have hard real-time restrictions and requirements. If you've got hard real-time or even some soft real-time workloads and need really strong predictability, for us, we found EC2 to fit that bill a little bit better than Lambda, although there are always advances on the Lambda side to make the start times faster and faster and maybe more tenable in the future. But for us, right now, that means EC2. Another good strong one is atypical protocols. If it's HTTPS, if it's an event like Avro, protocol buffs, JSON payloads even, something like that's probably fine for Lambda. But we have things like SIP, or maybe even more esoterically, things like SRTP, streaming protocols that don't necessarily fit very well with the Lambda runtime. And then finally, sort of the opposite of the short-lived, but not exactly, is fixed volume. So there are cases where even short-running functions, the frequency of them executing and the amount of it, if it's incredibly predictable, if you can have very strong sawtooth patterns, but very long periods where you need to run it continuously, EC2 can also be more cost effective. There are a number of different models online. There's some tools that you can use and plug that in to see where the breakpoint is for given hardware types on EC2 versus Lambda. But at a certain point, it actually makes more sense economically to run those workloads on EC2. So if that's sort of what it is and when we choose it, what does it look like? This is a blueprint, an example of what we have today. This is just a few example ideas of services that would be inside of our ecosystem. On the far sort of bottom left quadrant, you'll see a user. They're interacting with Route 53, serverless. We use it for service discovery, obviously also for classic DNS patterns. We send our traffic through CloudFront. We do that for CDN, for content distribution, but we also use it as a POP, an ingress point for our API calls to get those as close as possible to users. And again, we're able to do that entirely declaratively, right? No infrastructure definition, just a distribution and where it needs to be around the world. Now that talks to our public API tier, which can do scatter gather across those hundreds of services that I've mentioned. So it can talk to a Lambda that may, for example, be directly invoked. We tend to not favor that pattern as much anymore. For the most part, we put our Lambdas even within the interior of our VPC behind ALBs, sometimes API gateways, but we tend to go more towards the application load balancers. And we do that for a couple of reasons, but not the least of which is hiding implementation details from invokers. So that's a good, strong pattern that I think would help you long-term in making switches and transitions in your architecture. Make sure even if you have serverless in the mix, if you're doing a request response paradigm at least, having something like an ALB or an API gateway in front of them is a pretty strong, a powerful move to have portability, to have flexibility in the future. Those Lambdas, though, can talk to a number of different things. They can talk to a Dynamo table, for example. That's what many of ours do. Again, serverless there. We have DynamoDB streams, for example, that may be plumbed out to other Lambdas and write index files into Elasticsearch, where we might actually be running that on top of EC2, a serverful workload being a data tier that's different. On the other side of it, though, our event bus on the back end is Kafka. That predates a lot of other capabilities that are in AWS for us. And it's the workhorse that we've got. And it's also stringently held to those demands that I mentioned around hard real-time characteristics. So we have that as the way that we shunt information between services as a way to bridge that gap between that event bus and Lambda. We actually have a microservice today that can basically forward the information, the events flowing over Kafka, over to places like a Kinesis stream, to NSNS topic for notification, to SQS for background asynchronous work. Often, though, you'll see something like a Kinesis stream or a Firehose being used to write event archives off into S3. And one of the workloads that we can still support with serverless from the front end is queries over that data set through something like Athena. So that's how many of our reporting systems might work for batch sort of OLAP style query patterns and ad hoc query patterns. So great, we like to use it. We bias our users, our engineers to go towards it, but has it been not fraught with peril? No, there are definitely dragons there that have to be slain. The challenges and sort of pitfalls that we faced along the way, these are a few of them, but they're, I think, probably common, and they're not unique enough to Genesis Cloud that they're not worth you thinking about. Concurrency is one of the first ones that people encounter that they need to actively manage. Know that it's obviously subject to regional quota that's shared across all of the Lambda functions within the region. But there are some ways that you can sub-manage that. There's pure sharing of unreserved capacity across all of your functions. You can reserve and have a limit on how much can be consumed, but that reserves that bit of your quota for a particular function. And then there's provisioned, which is sort of the far end of this. That's getting a little bit back towards infrastructure provisioning, where you've got warm functions already running. So you know that there's a certain amount of container time that's actually being spent, and there's a cost associated with that. So where we've gravitated is right in the middle. Reserved capacity, reserved concurrency is what we use extensively across our Lambda fleet. That being said, there are upper bounds and limits that you've got there. And you may find that it's a rather blunt instrument to try to decide how to divide your Lambda quota. And a mitigation that you would want to look into early is multi-account. So we've started down this path within the last year or two, having multiple AWS accounts. We already separate our development and testing environments from our production ones, But even within production now, we can have multiple accounts broken up by service family or groups of services, if you will, and share certain things like VPC using AWS organizations and RAM, Resource Access Manager, to do that. But this also allows you to sort of sequester groups of Lambdas that are associated with each other together and for them to share quota in ways that are a little more complex than you would be able to do otherwise. But it requires upfront work. That's hard to do after the fact, so I would suggest thinking about that early. Now there's service limits. Many of those are well known. There's memory limits on your Lambda. There's timeouts. There are a few that get a little maybe less visible or less known. Invocation payload sizes, synchronous versus asynchronous, for example, have different size that you can put in a request. Deployment size is also different. That's gone up in time, again, as the Lambda team has become more and more generous. Up to 250 megs now of unzipped payload if you go that route, or up to 10 gigs if you've gone with the newer container offering. But there are some trickier limits that you should be aware of. Things like an invocation rate. In addition to concurrency, there's a request rate that you can have for invokes. It's usually 10 times your concurrency is the rule of thumb. But know that there are some rate limits that are applied there as well. There's also burst concurrency, the speed at which you can spin up additional containers, if you will, the workers behind the scenes that host your Lambdas. So be aware that burst concurrency exists. There's a speed at which you can effectively scale out the Lambda fleet, and that differs by region. So know that those limits are there, know that some regional differences are there, and know that as you change your soft limits, having a good system in place of monitoring that, a process with your account team, your TAMs, etc., to kind of keep track of regional divergences to try to keep things aligned with your usage across the globe if you're global like we are. One of the first things that gave us pause trying to get to Lambda was VPC connectivity. We knew that we had many services that we wanted to use, that we wanted to put atop Lambda, but the things that they needed to communicate with were within the VPC. And we've got strong regulatory guidelines and restrictions, a security profile that we couldn't necessarily expose that. We didn't want to go out the front door to the public API for every single microservice request. So we waited until VPC attachment finally came along. And like many of you who probably lived through that, we fought with the cold start times of VPC attachment. If you have not come back since those darker days, know that Hyperplane and what it brought to the party has vastly improved that. So now the cold start time that you have to deal with is not related to the actual cold start of the instance. The attach time isn't related to the cold start. It's related to the deployment of the Lambda. So know that that consistency is much, much better than it used to be. That being said, there's another limit that you can fall victim to on that front, and that's the ENIs that get created behind the scenes by Hyperplane are related to the pair of security group and availability zone, subnets, if you will. So each one of your pairs of those will actually be an ENI that gets used. And there's a limited number of those, obviously, within your VPC. So a way to mitigate some of that, if you find, like we did, that many of your Lambdas probably have the same egress profile, they talk to your VPC. Maybe it's an open 443 within the VPC, no communication out to the internet, etc. That's pretty common, and we block what it can talk to on ingress rules on the other services, so we can still get a good security perimeter. But that means we can do a thing that we don't normally do, but here you may find the need to do it. You can share your security groups across Lambdas, and doing it that way means you'll only have enough Hyperplane ENIs as the traffic demands. So if you have in subnets and in Lambdas, you would only have in ENIs being used. If you have different definitions for security groups for each, N times M is what you're going to end up with. So an explosion of those. Another thing that we found, IAM roles was another place where we faced explosion of resources. We follow least privilege. We have a different IAM role for every microservice. We started down the same path for Lambdas. That met with great challenge on Lambda, the hard limits that we have around roles within an account. Again, the same mitigation that I mentioned earlier around concurrency is something you can use here. You can obviously segregate by account, and then you have a whole different IAM role quota per account as a way to deal with that. And observability is always a challenge. We've focused and invested in it heavily throughout our lives building on AWS for all those years. And I would say the differences between a serverless world and monitoring and the server for one look at things like Lambda extensions. Make sure that you're plumbing information like logging, aggregation, or metric telemetry data to your partners, your vendors, as efficiently as you can. And Lambda extensions offers better ways to do that now. But know that the things you monitor may be subtly different, right? Focus on transactional telemetry. If you're using something like the Open Tracing Standards, Open Telemetry, many vendors, third-party APM vendors, for example, offer distributed tracing. Focus a lot more effort there than on the more classic metric aggregates, and that will serve you well. And from a concurrency standpoint, make sure, in addition to things like invokes, durations, and errors, that you also look at the percentage of concurrency being used and the percentage of reservations being used. Right? That's a good one to stay ahead of as well. So that's how. And what about why? Why do we do this? The most classic one that people jump to is obviously cost management. There is a better cost profile that you can achieve. You're going with a true usage-based billing model with Lambda. That's great. I think this is another place where it extends outside of compute and goes into the other tiers as well. Back to the Dynamo example. For us, when we started, we were going with the Dynamo route of we have provisioned IOPS, read and write IOPS. We moved quickly into having our own automation, open source tooling that would do scaling of those IOPS as demand changed. Obviously, we moved to the native AWS scaling of Dynamo as we moved forward. But those are reactive, right? And we needed something to get ahead of that. And what we found now with on-demand is that meets the need for us. For Tier 0 and Tier 1, our most critical workloads, we've moved a majority of that usage pattern over to on-demand. So know that there is a premium for that model, right? There is a cost premium for using it in that way. But what we found was that, particularly for workloads that are very spiky, and the real world tends to be very spiky for us, the area under the curve was large enough that it consumed the waste of the higher premium that was there for on-demand, right? So it was actually both cheaper and it scaled quicker for us than going the classic route of provisioned and auto-scaling. Beyond just that, its scaling primitives are different with serverless. I've mentioned that the currency is different. I think it's important to say, looking at something like Lambda and saying we can do 50 of these business actions at the same time, as opposed to at 70% CPU, I need more resources in the cluster. That's an important distinction. It's a different way to think about a problem, and I think it keeps your engineering teams closer to it. And that's the right way to think. There's independent failure domains. Again, least privilege is great. We have microservices that follow the SRP, single responsibility principle, vertical slices of functionality. It's good to do the same thing in Lambda, and you can obviously make it smaller. It's encouraged. In fact, it's hard to not do with Lambda. So I think that it just encourages good practices there. We found regional independence is good. It's pretty easy now to do that kind of thing with EC2 as well, with things like Transit Gateway, but it's certainly easy to plumb your event sources so that you can go cross-region if you choose to. Our compliance teams like it. There's less focus on runtime security and more focus on application security. That's a good trade-off. Smaller audit domains when it comes to things like PCI audits, for example, if you're lowering the profile of what needs to be touched, that's goodness there. And again, the meta theme here is you get to focus more on business problems with Lambda, with serverless in general. And I think that's the right way to go. So I'll close the benefits with this. We're a platform. We want to be able to enable our users, whether partners or direct customers inside of our ecosystem, and serverless has a part to play inside of that story. Specifically this, we are now a partner event source for Amazon EventBridge. So that means whether we're talking about customer experience events, transactions, a call, a chat, proactive offer, a predictive engagement transaction that comes through customer journey, those can be plumbed. Workforce engagement events can be plumbed over to an event bus, and that goes to our customers or our partners' AWS accounts. And they can connect that very easily with the serverless side of the equation. They can plumb it into something like Lambda and take actions, business logic rules be applied. They can send it to SNS and have notifications being delivered. They could use Firehose and maybe deliver it to their own archive along with other back office systems and have an audit stream that combines those together in a meaningful way. So I guess within Genesys Cloud, serverless was great for us to get speed and reliability, to be able to focus on business problems over the infrastructure ones. And all of those stories play equally as well on the outside of the company with both our partners and our customers. So if you haven't already taken your serverless journey, I'd encourage you to take a look again more closely. Hopefully some of the challenges we've faced, how we've done things, and the benefits that we've seen will also be instructive along your journey as well. Thank you for your time. And Jean, back to you.
Okay, thank you very much, Glenn. I think this brings great value to identify, okay, what serverless means for a company like yours, how you're using it, what are the criteria that you use to select where to put serverless workloads, and what are the challenges that come with bringing serverless services into your stack. And I think it brings great value, and I hope everyone enjoyed this session. Please complete the survey. It helps us improve over time. Thank you very much for your time.